Hello, everybody.
Hello.
Hello, Carlo.
Hello.
How are you doing? Long time
I'm
no
good.
speak.
And you?
I'm fine.
Sounds
Well,
great.
thanks for joining, everybody, wherever you are watching us from. A disclaimer, this is the first time we do it. I expect a lot of technical difficulties. It's actually the first time we use this platform as well, aren't we? Or have you used it before, Carlo?
No, actually, this is the first time for me too. So,
Okay, we'll see how it goes. But if anything goes wrong, then I hope that you won't be too disappointed at us. So we have quite an ambitious plan for the upcoming days and for today as well. And we are running these sessions under the umbrella of Azure Skåne community, which is the community that is located in the southern part of Sweden, as you can see here on that part, actually in the city of Malmö. And both Carlo and I are members of the community, and we are watching all the sessions that are going on there, and we really enjoy it. And we thought that during those summer months, not a lot is going on. And I know as a fact that a lot of people are very curious and they are struggling to find time to learn new things. So it only looked like the perfect situation for us to do a number of sessions where we discuss about what, Carlo?
we will discuss more about especially the EOT hub and things that we can find
The
in Azure.
Azure IoT suite. And
Yeah.
before we go into the details, a few more things about the community. If you are going to say something, hopefully something positive about it in Twitter, then please use the hashtag Azure Skåne. And of course, you can follow the community on LinkedIn, Twitter, and YouTube. And you have all the links here as well. And we also have a little surprise for you. This, my dear friends, is a learner badge. This is an NFT token which you can scan with your mobile phone, and then you can save this token as a token of appreciation that you attended this session. And then there are a lot of people who are collecting those, and we usually compare them when we're meeting conferences, don't we, Carlo? I mean,
Yeah,
it's
that's true.
kind of a nice thing to have many of those. And okay, the learner badge is not a particularly rare one, but there are others that are very rare, and having one means a lot. Now, enough with the shenanigans. Maybe when we go through the agenda, we can say a few words about ourselves. Would you mind to begin, Carlo? Who are you and what do you do?
Yeah, so my name is Carlo Goretti, and I'm 23 years old, software engineer, and currently working at Helo here in Malmö. So I'm usually a backend developer, I would say, but yeah, pretty new, but still pretty like
Still going
much
strong.
knowledge. Yeah, I want to learn.
Yeah, yeah, you are a fierce one. And my name is Nico Stellis, and I am 34 years old, so a bit older than Carlo. I still feel a developer in the heart, but currently I also work at Hello, like Carlos. We are colleagues, not only friends, and we share many common interests, such as Azure, on which I usually do architecture, but also some DevOps and, of course, development, solution development. Now, about the agenda and about what we're going to do the upcoming days. First of all, today we are going to speak about the basics of IoT and especially about Azure IoT. we are going to have a little project, a simple project, which we are going to develop in front of you live, hopefully. Hopefully, it will work. We have had some small challenges, but we have prepared. And I do believe that it will go very well and that we will be able to present all the important things you need to know if you want to start with Azure IoT. As I mentioned in various LinkedIn posts and Twitter posts, you do not need to have any knowledge okay, some basic knowledge might help, but these sessions are for beginners, and you're going to be able to follow no matter what is your background. And if you don't, then please let me know, and we will try to keep it as simple as possible. Then regarding the second day, tomorrow, we're going to take a deeper dive and we're going to see how we can present the data that came from the little project that we're starting today. The program for the third day is not yet completed because we are waiting for another special guest, like the one that we're going to have on Thursday, where we're going to have an Ask Me Anything session with Maria Anastasia Mustaka, which is a Microsoft MVP within Azure IoT. And last but not least, in day 5 on Friday, we're going to have a summary, and maybe we're going to for an after work beer or something. Anything you would like to add, Carlo, or should we start talking IoT?
Yeah, I think we should start. It was pretty good.
Okay, thanks. Now, here is the description of the little project that we're going to build. And as it says here, it just send me an email if it gets hot. So we are going to have a virtual sensor. Unfortunately, we couldn't arrange a real thermometer or something that could transmit data without bringing devices. And then since we stream this and we're doing virtually the whole thing, it wasn't so easy for us. So we're going to do this part virtually, but yet again, you don't need to have real things to test those things. Then we are going to, from the sensor, we're going to send the temperature data to the Azure IoT Hub. And from there, we're going to do some other nice things. And of course, we'll go through them in detail as we do them. And hopefully, if everything goes well, then we will have an email in our mailbox saying that, hey, this is now getting hot. So before starting the coding part and the Azure part, let us say a few words about Azure IoT. First of all, IoT, it stands for Internet of Things. And you and I, Carlo, we share a project together with robots and stuff. And there we do have a lot of things where we get data from. Um, what do you think about that project? How do you think that Azure IoT has enabled us to create functionality?
Yeah, yeah, I think that when we use the Azure IoT Hub, for example, we can enable the digitalization of the things that we have in our robots and stuff. So we can take the data that they are producing, send it to Azure, and manipulate it and do things with it, like statistics, and we can do alarms and etc. So we can easily monitor them in a digital way.
That's exactly right, and I like to encapsulate all those actions under the name awareness. What we are trying to do using Azure IoT is to provide awareness about what the robots are doing, awareness about what in every subsystem is happening, awareness about pretty much anything. So Internet of Things does have to include hardware, if you want my opinion, but it doesn't really have to do with the hardware parts of it. So you can have any devices that produce any types of data, and then you somehow need to extract knowledge from the data. So example-wise, for this sensor that we have in our little project right here, the sensor saying that the temperature is 20 degrees every other second is a lot of data, but it doesn't really say a lot if we cannot make use of it. And maybe what we're interested in is what happens if the temperature gets 20%, 20 degrees or 21 degrees, Celsius degrees, I'm talking always. So everything, small or big, produces data, and all those things, which is why we call it the Internet of Things, need somehow to cooperate or need to speak their voice simultaneously. And since we have that much data, we need tools that are able to aggregate this data, that are able to send the data to various sources, that are able to accumulate the data so that we can perform various actions on them, so that we can perform anomaly detection, maybe, so that we can get the average values, and so on and so forth. And Azure has a lot of tools that help us perform those actions quite easily. And one of the most important ones, maybe the one that we can't live without, is the Azure IoT Hub. Now, here is the part where I believe that if you have some knowledge about Azure, it will be helpful, because there is another hub, very well known, called the Event Hub. And this one is similar, but as you will see in a couple of minutes, it provides functionality that the other one does not. So the Event Hub is the perfect tool if you want to stream loads and loads of data. And the Azure IoT Hub is the same thing, but it also has functionality that enables you to connect devices to the Azure IoT Hub. So Microsoft have conveniently thought that we're going to need to connect and send data to the IoT Hub using various sources and various ways. So there is, for example, the MQTT, the Mosquito receiver, which is a message broker that is quite well adopted in the industry. But there are also very simple ways to register devices and get them sending data within seconds. On top of that, the Azure IoT Hub has various ways to send the data. Oh, sorry for that. Very, very sorry for that. Let me just, of course, there you go. Of course, the Azure IoT Hub provides possibilities to send the data further on, or enables tools to get data from the Azure IoT Hub, such as the Azure Functions, which can get the data like an event grid topic, and such as the stream analytics job, which we hopefully will be able to show tomorrow. And there is also a Defender, which is something that Microsoft has built to make sure that data is safe and that not dirty data is getting in the way, producing problems which we don't want. And I think that with that, we might be able to start coding. What do you say, Carlo? Are we ready for that?
Yeah, I think so.
Yeah.
So
Before
I will take
sharing your screen, let's say what we're going to do. First, Carlo is going to create a sensor, and then, or no, sorry. First, I will create the Azure IoT Hub, and then I will register a device, the virtual device which Carlo is going to use. And then Carlo is going to create a virtual sensor that is sending temperatures to the IoT Hub. And then the Azure function will pick those temperatures. And if the temperature is over, I don't know, what do we say, Carlo? Maybe 22, 23?
Yeah.
Yeah. Then it asks a logic app to send an email, which hopefully will land in my inbox. So let me start by creating the IoT hub. Just right now, show you my screen. How does it look like?
It looks like good. It looks good.
It looks good. Okay, maybe zoom a little.
Yeah, maybe a little bit more. Yeah, now I think it's good.
No, I think it's good as well. Okay. Let's see. So I am in my resource group, and I am going to create a new resource, and I'm looking for the IoT hub. Create. Let's see what we're going to change here. So I have my subscription, I have my research group. Let's call it something like IoT, Azure Bootcamp Hub, something like that, yeah. And we will put it in the West Europe region, which is close to us. And then the standard here is quite okay. And as you can see, the pricing is dependent on the number of messages that we're going to send. On this point, Carlo, do you remember when we had the issue that we reached the limit of messages in the IoT hub?
Yeah.
Yeah, so a lesson learned there, at least for me, is that do you really need to send every little thing that happens to the IoT hub? Or maybe you can perform some actions on the edge, as I usually call it, so at the device. And of course, this is going to be more than enough for today's session. But for the future, we have to keep in mind that those numbers are not endless, and you can actually have problems with that. Networking, yeah, let's give it public access. Of course, it's not recommended. Of course, you have to create a private endpoint if this was a real project. But for now, we want to keep things simple. Let's go with the public access. The shared access policy is a known danger. You should avoid using it. And of course, it is what we're going to use, right, Carlo?
Yeah.
Because it is the easiest way to connect, actually. Enable the device update for no, we don't need that. And the Defender, of course, since it costs so little also. And I won't be using any text today. And now let's review it and create it. Okay, and now it will take a couple of minutes.
Nice.
It shouldn't take long at all, maybe 2 or 3 minutes. During this time, Carlo, what kind of application are you going to use to create a virtual sensor?
So in this case, we will use C# and .NET to create a console application, which will have 2 methods and a little bit more. That one method will generate a random temperature, and the other one will be the one that sends the data. So pretty small console application, but yeah.
So a simple .NET application, console application that does not do a lot. Just a timer generating like every how often would you have it?
Maybe like maybe 2 or 5 seconds. pretty
Yeah,
fast.
something
But
like that. Something like that, yeah. So, but as you can see here, the first thing before, of course, you can create your app, but you won't be able to send any data anywhere if you don't have the connection strings, and those are going to be derived from the Azure IoT Hub. So let's give it another minute. It does take some time, but it's worth the waiting, and you only need to do it once. Recently, you started writing infrastructure as code to create the IoT Hub, Carlo, right? What were you using? Was it Bicep
no, actually, it was Terraform in this case.
or Terraform? Okay. And did you manage to create a hub using Terraform, and what else?
Yeah, so I used the Terraform and Azure RM provider. It's like a built-in provider from Terraform, so you can manage the Azure resources.
Yeah, yeah. And just to mention what the difference between Terraform and Bicep is, Terraform is actually the big player in that market, because you can use it to create resources in not only Azure but also AWS and Google Cloud, and possibly even other cloud service providers. While Bicep is Microsoft's take on how you should create resources in Microsoft Azure, as well as ARM templates. Actually, Bicep is going to be being compiled to ARM templates, but Bicep is much more readable and much easier to use than the ARM template. Now this should be ready any second now. Let's see the operation. Oh, okay, of course everything is hidden. There, almost done. Almost done. Deployment in progress. But this seems okay. So what if I refresh? Okay. Let's wait. Let's give it a minute or two. In the meantime, let's see if we have any messages. Marcus from Sweden says, "Hi there." Well, hello you, Marcus. Thanks for being here. Martin also says, "Hi all." Hi to you, Martin. And Lazarus also says, "Hi folks." Hi, Lazarus. Hi. Okay, no other messages. Actually, this is now streaming in YouTube, in my personal channel, and in Azure Skåne channel, as well as in LinkedIn. So if anybody is watching from LinkedIn, please drop us a message and let us know. Oh, look at that. We got the service unavailable, of course. Oh, it retried and it succeeded, apparently. Didn't it? Yeah. Now we have up here a warning saying that this research uses a certificate on the Baltimore Cyber Trust route, which will expire in 2025 and must be migrated to the DigiCert Global G2 route. To avoid service disruption, it must be migrated by September 15th, 2023. So keep that in mind. If you are using it currently, then please do. So this is the IoT Hub, and as you can see, you get directly some stats right here. How much you have used today out of those 400,000 messages that we selected, how many devices, and then you can also see the number of messages that are incoming, and then the number of device to cloud messages, how many devices you have connected at every minute, as well as the total IoT devices. Now, of course, today we're only going to have one device, but keep in mind that those stuff are built for supporting hundreds of devices. So, without any waiting, let's. Or shall we go through a little bit of the settings here, Carlo?
Yeah, maybe that would be good.
Yeah. Yes. So here we have the overview, as I mentioned, with some basic data. And then we have the activity log and the access control, basic stuff. The events is where all the magic happens. So this is where we come to pick the data that the sensor is sending. Then we have the devices, which is where we register all the devices that are going to send data to the IoT hub, and we also have the IoT edge devices, which are enhanced. Let's call them enhanced. It's actually software. They don't have, they're not real devices. It's software, but those installations can do a lot of Azure stuff on the edge. And then configurations and deployments, those are tools to automate the deployment of IoT modules. And we also have updates if we need to update our devices. And here are some built-in endpoints for us. If we want, those consumer groups are quite important. I usually create one group for each device, but this is more related to the stream analytics job, which we're going to talk about tomorrow. For how long we're going to retain the messages? Now remember that the IoT hub is not going to send the messages somewhere. The messages are going to arrive by the devices, and the IoT hub is going to wait until someone comes and pick them. And this is how long am I going to wait? Where you're going to wait for a day for this time. Then pricing, of course, and properties, and we have the identity here. I will not really create one right now, but we would use that for our password connectivity, because we don't really want to send passwords here and there. And with that said, I believe that we have covered the basics. So now it's time to create a device. So it's very, very simple. Let's give it an ID. What shall we call it? So we call it Carlos temperature sensor. It is not going to be an edge device. It's going to be a simple device. The authentication types will be a symmetric key. Auto-generate everything and connect this device, of course. So let's save that. Now this also takes a second or two. Okay, it didn't take much more than that. So as you can see, when I open the device, luckily everything is hidden, but I will make sure to copy that one and to send it to Carlo. And this primary connection string is all that Carlo needs to be able to send messages to the Azure IoT hub. And I believe that with that said, it's time for you, Carlo, to start writing the application. Could you share your screen, please?
Yeah, let's see.
Yeah. I see that I didn't change the background of us. Let's put the fruit salad. So, great. Okay.
So, can you see my screen now?
Yes, we can.
Nice. So let's start with this. As I said before, at this moment we will build a console application with C# and .NET, especially .NET 7 this time. Pretty simple console application, just like doing an emulator so we can get some data. So let's start. I will name it as this. So IoT temperature sensor, pretty basic and straightforward. So let's create this one. And here you can see we get empty.
You have to zoom in a little bit.
Yeah. Let's see. Is it better now or?
That's perfect. That's perfect. That's perfect.
Nice.
So let's take it step by step, Carlo. So
yeah,
we have a console application, and the console application is now about to start. So what happens first?
So first of all, we need to get a temperature, and at our case, we need to get a random temperature for the most fun part.
Yeah.
So we can start with that. We can create a method. We will create a method that we will that will create a random generated temperature and just console it at the start. We don't need to send it to the Azure at the moment. So at the beginning, we can create a void method that we can call generate temperature. And we will not send any in parameters for that. So what will this method do? Yeah, it will create a random generated double at this point, so we can get like 24.6 and stuff. So first of all, we can create a double variable called maybe temperature, which will have 0 at the moment because we don't know it yet.
Yep.
And then we need to create a we need a random generator or random object which can do the actual randomness. So let's create a random, and this one we can call random as well. Equals a new object of random.
Yes. So you're using the .NET randomizer to generate random values.
The built-in
Sounds
one.
very good. Yeah.
So now when we have the random generator, we can do we can actually what it's called. I have forgot it. We can give the value.
Yeah. Exactly.
We can. I have forgotten
get the random value using the randomizer.
So
between.
And you see here we have the next double, but the problem here is that the next double is, as it says here, it only takes a random number between 0 and 1.0 or 1.0. So what we need to do is that we need to take next double, multiply it with, in our case, we maybe want a degree between 20 and 25 degrees. So we can say 20, 25 minus 20. So we get the difference there and multiplies it with the next double, which will do the randomness between 0 and 1.0. So, and with this, we will add the minimum value of these two, and this is just for this one will give us the 0 point something number, and this one will multiply it.
So I guess you could just write 5 there in the multiplication. Yeah, 25 minus 20.
Yeah, we can do that actually. Yeah, the meaning of doing in the parentheses is more if you want for example, you can send those two as an input parameter, so you can customize it more. But in this case, we can say 5.
Yeah. Yeah, that sounds right. Yeah.
And after this, we can try to console write-line it, and we'll console write-line the temperature. And to be able to get the actual console write-line, we need to do a call the method. So we can do a generate temperature, semicolon, and call it. And this one should hopefully, usually when we do a demo, it often get something else.
Everything breaks. Yeah.
Yeah, so this one should work, but I can't promise anything. So let's see. Yeah. So for example, now we got 24, and if we do it again, we should get something else. So yeah. So now we know that we get a random temperature generating for us. But the problem here is that we don't want to console write-line it, right? Because we will send it to Azure. So instead of doing it as a void method, we can do it as a double that this method will return a double.
Mm-hmm.
So we can use the value later. So here we can take return temperature. So we instead get the temperature from this one.
Mm-hmm.
So now we can say that the method is ready to use. So the next point here is to that as you saw, when we run the program, we only get one value and then it turns off. So what we want this time, we want it to interactively run all the time and set a timer on it. So it runs maybe every 5 seconds or 2 seconds or whatever you would like.
Yeah. So you are trying to emulate the behavior of a sensor that speaks its voice every 5 seconds or something like that.
Yeah, exactly. So in a real case scenario, it would be a sensor that sends the data all the time.
Of course.
So, but first of all, we can do so. As you saw, when we started the program, it do it one time and then it turns off, and that's because it's a console application. So it just runs from start to end. So what we can do here is that we do a try and catch that maybe many of you are familiar with.
Mm-hmm.
And in the try block, we can do a console dot in, that is the text reader, and then peak.
Yeah, and what you're doing there is that you are trying to halt the program so that it doesn't close until you press any key by yourself, right?
Yeah, exactly.
Yeah.
And so we can get that running all the time.
Yes.
So now when we have the try block, we need to have a catch block in case of anything happens. So here we can say for this simple project, we can just do an exception and catch it. So here we can, for example, do a console write line that says we got an exception. And then we can say with curly brackets, we can string interpolate it and say what we got for and what message we got for the exception.
Mm-hmm.
And then we also need to say that let's see. No, I mean now when we have the console write line, we can do this is kind of a logging, but we can also have in a bigger project we could have a real log system instead.
Of course, yeah.
Yeah. But we will also have a bool that says if it's interactive or not. So we know.
We start by assuming that it is interactive.
Yeah.
So we set as to true, and if peak goes wrong, then
we set it to interactive equals false.
Yeah.
And then after this, we also checks if the is interactive is true or not, and depending on that, we say console.readline.
Yes. So that's how we await console application. Now, this doesn't have to do with our IoT things, of course, but it's good that Carlo is saying that.
Yeah.
Yes, because we want our console application to run forever. That's why we're doing those things.
Yeah,
great.
At least in this case. So now when we have this, we can try to run this just to see that it will not stop this time.
Mm-hmm.
So it will run this and, oh, sorry.
But it won't print anything, right?
Yeah, because we have commented it out. So at least you see that it's not stopping anymore.
Yeah.
And it's, if we would press any key, then it would stop.
Yeah. Cool.
So we can, first of all, we can remove this hello world because we don't need that anymore. And yeah, so now we need a timer that can actually generating this temperature every 5 seconds, for example. So we can start creating a timer here. Timer. In this case, we need a system.timers. This is pretty important to know because many times, including me, myself, I have gotten this one. And this one is the wrong one when it comes to doing like this because it will often give you errors.
Yeah.
So timer, and we can call this as simple as timer equals new timer. So we get a new timer. And before we start this timer, we need to set some set some properties of it. So, for example, we need to say for how long should the interval be. And in our case, we want to have 5 seconds. But instead, when we hover over the interval, it says that it should be in milliseconds. So you could either write 5,000 for 5 seconds.
Because 5,000 milliseconds is 5 seconds, but you don't have to calculate it in your head. You can do it with times one, right?
Yeah, so that's the easier choice. And in my opinion, more clean. So
I agree.
From seconds, in our case, we say 5 seconds. We want to get the total milliseconds.
Yeah. So that's much more readable than writing 5,000 or whatever, because you both can see the number of seconds, which everybody understands, and you can see that the value you're putting there are milliseconds. Very good.
Yeah. So now when we have the timer, and we have the interval, we need to tell the timer that what should it do when the when the time interval has elapsed. Yeah. So in this case, we do timer dot elapsed, which is a event function. And we can say that we want to plus equal. So we give it, and directly we see that it wants a delegate method. So we can do an anonymous function, or we can do like a regular function. But in this case, I personally prefer more like anonymous function. So we can say that we'll have an anonymous function which has source and source and e as input parameters, and the source is of course the timer, and the e is like the actual event that happened. So yeah, we say here we do an arrow function and curly brackets and close it. So this is pretty familiar with, if you're familiar with JavaScript, you probably recognize this a lot because that's...
if they're familiar with JavaScript, then maybe they're not in the stream. But sure, yeah. I get your point, yeah.
So
it's like a timeout, yeah.
Yeah, it's pretty common. And here we want to have here we want to save the actual, do a new variable which will hold the temperature that we will generate from the method we created above. Because as we did before, we said that this method should return a double. So here we want to catch the actual double that comes from it. So we create a new variable that is called generated temperature. And we declare it to, we can call the method generate temperature and semicolon, so we close it. So what this will do now is that every time this time interval elapses, then it will then call the method and get to generate the temperature. But we don't really do anything with it at the moment. So for example, we can do as we did before. We can just do a console.writeLine to see the actual value that we actually getting something from the from this method.
Yes.
So now we are when we have done this, still haven't told the timer that you can start when we start the program. So what we need to do here now is that we tell the timer that timer.enabled equals true.
Yeah. So what happens if you run now?
When we run now, we should the timer should start and start ticking the seconds. And when it comes to 5 seconds, it should run the generate temperature method, get the temperature back, and console write it to us.
Yeah. So every 5 seconds we get a random temperature, right?
Yeah.
Would you like to give it a spin to see how it performs?
Yeah. Let's see.
Okay, let's see. 1, 2, 3, 4, 5. Done. That's 5 seconds. And 1, 2, 3. Oh, okay. 21 point something, 23 point something. Yay. Looks perfect, Carlo. So now we have a sensor that produces random temperatures every 5 seconds. So what we want to do now is that we want to send those temperatures to the Azure IoT hub. And how are we doing this, Carlo?
We can do this through that another method that we can create. I like to do it in method way because it's more clean. So above here, we can create a new method called let's see, called send to Azure async, because in this case, when we work with the Azure parts, it's usually asynchronous. It's called, right, Nikos?
Yeah. That's right. Yeah.
So and when we do use the async methods, we always need to have async and task.
Yeah.
Just to tell it that this method, when you run this, it should be it should be run asynchronously, or you should await it.
Yes.
But it will not block the thread in this case.
No. So before you write the commands, what you're going to do right now is that you're going to connect to the IoT hub, you're going to create a message, and you're going to send it to the hub, right?
Yeah.
Okay. Let's go.
Yeah. So what this method will do is, first of all, you need to take a message in, the actual message that we want to send to the Azure. So in this case, we know that we will get a temperature of type double. So we can say that we want an in parameter that is double and called message, for example. And in the actual method, we can start doing like this, that we will create, no, sorry. First of all, we need to get the actual NuGet packages for the Azure IoT hub and device.
Of course. The NuGet packages are the libraries that contain all the tools we need to interact with the IoT hub.
Yeah.
So let's see it real quickly.
Let's see if we can do it bigger. So first of all, we need to have Microsoft dot Azure dot devices.
Yes.
So this one, we can install this one at first. And then we need another one that is called, let's see if we, so devices.client. So with these two NuGet libraries, we will be able to communicate with Azure through our code. Let's see, we will do it like this. So from now on, we can create. We have the message here that we get as an in parameter, but in this case, it's a double. And when what we want to do is we want to create a new variable that is called, for example, we'll do it like this, MSG for message, but in this case, it will not be a double. It will be a Azure Devices Client message. So this is the type that Microsoft provides us through the NuGet libraries. So we easily can send the actual message later on in the method.
Mm-hmm.
So we'll create this message equals new message. And as the constructor, we need to say, we need to give it a byte array.
Bytes, yeah, exactly. It needs the bytes array.
So what we would do here, we would take the encoding UTF-8.getBytes, and here we will send the actual message to string.
As a string, yeah.
Yeah, so we will take the message that the user sent in, double, and then create a byte array from it, and after that create a message that Azure can use. We will also, because in some cases maybe something happens in the code and so on. So in some cases we want to do a retry if the message doesn't be able to send to Azure. So we can already now create a retry bool type. So we can say, in this case, it should be true because we don't know yet if the actual message has been sent or not. And we can also create a retry counter, which says how many times do you want to retry before we should leave it. And in this case, we should say 5, maybe. So when we'll do the actual sending of the message, we'll do it in a do and while.
In the do while loop, yeah.
Yeah.
So what Carlos says right now is that we're going to try for 5 times until we have a success.
Yeah. So the while should be as long as retry equals true, and the retry counter equal minus minus and greater than 0.
Yes. So first it will be 5, then it will be 4, 3, 2, and so on and so forth. Yeah.
That's good. And in the start of the do statement, we should set the retry equals to false because we don't want it to run again, and we hopefully doesn't get any errors, so we don't need to retry. But we can do a try in case of anything, so we can catch it if it gives you error. And this one needs a catch block. So, and in the try statement, we can send a message to the console just to know, so it's actually so we can like following up more when it actually sends the message, and when it actually sends the message, so we can follow that in the console. So first of all, in the console log, we want to see when does it try to send to Azure. So we set a null, I mean a 0, for the string interpolation, and we say that we want the datetime.now. So it actually takes the current date and time when it actually processes this. And then we can say that uploading data to Azure following message, and then curly brackets here, and again with 1 this time because this is the second parameter. And in this case we want to do the JSON serializer dot serialize message.
You can just okay, yeah.
Oh yeah, we
No, do it like that. It's fine. Do it like that.
yeah, but we can do that too, right?
Yeah.
Since it's a double and it's implicit converting it to string.
Yeah.
So the the actual reason why I want to show the message in the log is so we know that it sends different Azure messages. Just more to be precise. So after we have console log this one, we need to we will call the actual send event async method that Microsoft provides us.
Yes.
But before we do this, we need to create an actual device client which we can use. So if we go up here, we can create, first of all, we can create a var IoT connection string equals, and we can set this to empty string right now, just to declare it. And we will also create a device client, which is called device client. So later on, when we have these two variables, we want to, or we can actually do this right here, but we can instantiate it to device client dot create from connection string. Yes. So here we can send the actual IoT hub connection string that we will give it upper here. So from this we will get the actual device client, which we can use in our send method now to send the message to Azure. So now when we have this one, we can go down here again. So after the log, we want to use the device client, and we can say that device client dot, and here we have send event async, or you can send a batch async, but in our case we just want to send one message.
Yes.
And this one wants a message in, so we can take a message that we created up here, and send it in like this. And then we want to do a continue with, and this is for I've forgotten, Nikos. Maybe you can help.
You can skip that part. You don't need to check. You could check if the sending didn't go well, but you need to await this.
Yeah.
Because that's an async. Yeah.
So we'll have no, sorry. That.
Literally, yeah. That sounds good.
This one will give.
Did you take a wrong type of message? Yeah. So write the whole namespace. It should be.
Should it be
Azure devices client message? Devices dot client dot message. Yes.
Sorry.
Yeah, and the same in there. Yeah. So now this looks very, very good. And I think you need to catch the exception.
Yeah.
And if you end in the exception, then retry has to become true, right? So that you do retry.
Here, yeah.
Yeah.
Retry equals true.
Yes. Good.
And you can also do a console log here if you want for the
Yeah,
exception.
but yeah,
It's not necessary for this case. And
you only need to set the connection string now.
yeah, and actual
Yeah,
call the send to Azure async method.
exactly. So for that, you will need to get it from the app settings station, right?
Yeah. So we would.
Or do you want to do it? Do you want to do it last? Do you want to call the method first when the timer elapses?
Yeah, we can do that
Yeah,
first.
let's do that. Yeah.
So in here we can say that instead of console write line the actual temperature, we can say send to Azure async. And here we want to send the generated temperature that we have gotten up here.
Yeah.
And in this case, this is an async method, so we need to say here that this anonymous method will be async. We would say await here.
Brilliant. Yes. So every time the timer elapses, you are sending the temperature to Azure.
Yeah.
Okay. Now, while Carlo is taking the values from settings file from app settings station, let me say that in this particular scenario, the virtual sensor is going to send up all the temperatures, every single temperature. So we said that we only want to alarm if it gets too hot. So let's say we only want to send an email if we get temperature over 24, 23, maybe degrees or something. So in real life, at least in my opinion, it sounds smarter to perform this check at the device. You do not need to send all the other temperatures to Azure if you don't have any interest in them. If you only want to know in case the temperature gets high, then only send the one that's high. But in our example, we're going to do exactly as Carlo is doing, and we're going to send all the temperatures, and we're going to filter out the good one somewhere else.
Yeah.
Yes. So now you need an app settings station file.
Yeah, we can create that first.
Yeah.
So we can create a JSON file, which is called app settings. Yeah.
JSON.
Yeah.
Yeah, and you can leave it empty for the time being.
Yeah.
And do you want to copy the code part that gets the settings?
Yeah, we can actually do that.
Yeah.
Let's see. So we have this one. And
fantastic.
This one. Yeah.
You need some NuGet packages.
Yeah. Oh, sorry. Let's see. One more code block. That one.
Yes.
So for this one, we need to have some more NuGet packages. One of them is, let's see, was the
extensions,
configuration.
Microsoft extensions configuration. Yeah.
Extensions. So we need that one, and we also need that one.
Yeah. And those are just to use the tools that read settings from the app settings station file. And let's not forget to make sure that the app settings station file is getting copied every time that we build a project.
Yeah, so you do that within the properties for the file. You go down here and take copy always, so to the actual output directory.
Yeah.
So let's see. So now we can take import. And now
it looks good. So now I am going to hide your screen, Carlo. For you to put the connection string in the app settings station file. So
Is it
You don't
hidden?
have any eyes of you. Yeah, it's hidden. It's hidden again.
Nice. Nice. Let's see. So now it's finished. So
Okay, and you're back. So, would you like to give it a try and see if it sends any temperatures?
yeah, let's see.
So, wait 5 seconds. Are we still printing them? I think we are, aren't we? Yeah.
No, but yeah, in the
It looks very good, I think. Fantastic. So, Carlo, you let this thing run, and I am now going to take over, okay?
yeah.
Great. So, back to me and my screen. And here we are in the Azure IoT Hub. And the messages, as you can see, they have already starting to arrive here. Those are the ones that Carlo is sending to us. So how are we going to pick those messages? We need something to pick them, and for this, a very simple way is to use an event subscription. So let's bring that up again. So now the sensor is sending the data to the IoT hub, and we want the Azure function to pick those messages, to filter out the high temperatures, and then to call a logic app that will send me an email. So the important one is the Azure function. So let's get it up and running. Let's create a new project for an Azure function. Let's call it function Azure IoT Bootcamp. And then what kind of trigger do I need? Of course, I need an event grid trigger. And why is that? Well, because as you can see here, when I create an event subscription, and let's call it SAB, Azure function. And the topic name could be Carlos temperatures. And then the event types that I'm interested in are not created, not deleted, not connected, not disconnected, but the telemetry. So it is the events that Carlo is sending that are of interest to me. And the endpoint time is going to be an Azure function. Now, before I do that, I have to create the Azure function, right? So let's create it first in code. As I started here, event grid trigger, yeah, and use the Azure rights. Sounds good. Very good, actually. And here it is. Carlo, is my code visible?
Yeah, we can see it.
Fantastic. I am using .NET 6. The simple stuff, nothing fancy at all. But before I do any fancy stuff, I want to deploy my function to Azure. And for me, the simplest way to do it is if I first create it in the same resource group as the IoT hub. So let's look for an Azure function. Function app, that's the one. Let's call it FN Azure IoT Bootcamp. Of course, I'm going to use .NET, the long-time support version, .NET 6. And let's deploy it in West Europe. Let's keep everything in the same region for good measure. Storage, yeah, sure, create everything you need. And public access, of course, why not? Application insights, of course. And no continuous deployment. And let's create the thing. Now, hopefully, this one will go much faster than the IoT hub. But we are in a live demo. Everything that can go wrong will go wrong. That's usually how those things go. but not this time, as it looks like, because it is almost ready. Almost there. So when my Azure function is ready, I am going to download its publish profile, which will allow me to deploy my code to the Azure function using only a couple of clicks. Now, of course, I do not suggest you to use that method. It is not a safe one, but it is a quick one. So if you just want to show something and you don't really care about the security of what you built, then that's a good way. So let's get the publish profile, and now it is downloaded, and as you can see, I have no functions at all. Nothing, absolutely nothing. But I can very, very easily now publish my function by just importing. Let me do it again. Right click on the project, publish, and let's do it from the beginning. Right click on the project, publish, and then I get this wizard up and import profile. Super, and then I have to upload the file that I have just downloaded. That's the one, and finish. And that was actually the end of it. Now every time that I click publish here, my code is going to be published on Azure. So we will give it a couple of seconds. And as you can see, it is publishing to Azure. And now when that is done, which should be done any second now. Yeah, it's that. Now the function should appear here now any second. Okay, it takes. Okay, now it's already up. Very, very good. So now we have deployed our code, our Azure function. So let's put some code in it so that it does stuff. So what is it doing right now? Right now, it is just going to log the information of the event in the application insights. So let's see how this is going. As I said, we have the function already. It exists. So let's go back to the research group. And let's go back to the IoT hub. Now I have everything in place. So we have our events here. And let's create a new event subscription. Let's call it SAB. Azure IoT Bootcamp. Of course, the event grid schema, I don't need to change that. The topic is irrelevant, but let's say Carlos temperatures. And as I said before, I'm only interested in the telemetry. And the endpoint type, you can see that you have multiple things here. So you can pick the messages using all those things. And I'm going to use an Azure function. And which one? The one that is in the same research group. And as you can see, the wizard has already identified everything for me. So if we confirm and create the subscription, now this will also take a couple of seconds. But this time for real, only... Carlo, is your application still running? Are we still getting results?
Yeah, it's still running.
It's still okay. So if I go to the overview now, yeah, you see, now this should not scare you. It says that the Azure IoT Hub may not function properly because it is not in active state. Now this is happening because we created the event subscription. So I believe that what is happening right now is that it kind of reset itself. So if we wait just a couple of seconds, I believe that it will disappear anytime soon. Now we already have 80 messages. So Carlo, could you please change your code so that it says every minute instead of every 5 seconds? Otherwise, it's going to rain emails in my temporary mailbox. Yeah, So now we're up again. We have one connected device. We have already received 116 messages, and I believe that even the event subscription has started to get something, or maybe not. Actually, this diagram here is a little bit slow, so you will get data here, but it might take a few seconds. Okay, so let's go back and take a look at the application insights to see if the function has said anything yet. Okay, some basic stuff. Of course, it's restarting itself, and now the moment that the function gets executed for the first time, we still have 0 executions. So, are you sending events, Carlo?
Yeah, but now I've changed it to 1 minute. So
To 1 minute, okay. Well, then let's wait a little bit. What I expect to happen, and since the code says that the only thing that it does is that it's going to print the data in application insights, is that when Carlos sensor is sending data, the Azure function picks it up and prints the data in application insights. So until this has happened a couple of times, let's see the comments. We have a few. Please zoom in a little bit. Of course, absolutely, I will, Marcus. And you are also saying that the JetBrains Rider looks nice. Current only Java idea about starting my .NET surgery with IoT. Wow, fantastic, Marcus. I'm very, very happy to hear it. And now the licenses, I think that the best price you can get is if you get them in the private license. I think is the cheapest one. No, this is still not getting executed, not even a single time, as I can see. Oh, yeah, well, it did. And how did it go? Yes, look at that, look at that. And the interesting part here is the body. Now, this is some nasty JSON, but we have the body property here. And this is a base 64 encoded string. So if we decode this base 64 string, then what does it say? Look at that. That is some nice temperature.
looks really good.
So yeah, it is. I really like it. So we are on conception tier, chip stuff, guys. Sorry, that's why. Yeah, here you see. Now we got an execution, and we're going to get one every minute. So let's make it do some funny stuff. So as you saw in application insights, the message is quite complicated. It has quite a lot of data, and I have created for us a couple of classes. Those that I have just pasted from my other window. And this is what the message looks like. Let's call it IoT message. So it has some system properties, which are properties that describe the message, and it has a body. And it was inside this body that all the magic was happening. So what we have to do right now is that we have to deserialize all those properties that are inside data. And data, as you can see, is binary data. So let's do like that. IoT methods. Oh, sorry, I should zoom a little bit more. Hopefully that's okay now. Great. IoT methods, let's call it methods. And I will use JSON convert to deserialize the object to an IoT message, of course. And let's take event grid, and let's take data. which of course needs to be converted to string. This looks good. So now what I have done is that I took the data and I have created an object of this class. So I have easier access to the body, which actually has all the interesting information. Now, as I mentioned earlier, the body is base 64 encoded string, so I need to decode it. And to do that, I get its bytes. Let's call it this message bytes. Message bytes by using convert again from a base 64 string. Message body, that's where the data is. And then let's convert this message bytes array to string. So let's call it string bytes string encoding UDF8 get string from the message bytes. So what I'm doing right here is that I'm reverting what Carlo did earlier. So let's see what we can do now. Log information. Okay, let's see, when was this NQ'd? I believe that we have this information actually, don't we? Right here, NQ time. So if I take the IoT, the message system properties, and I have the NQ, what is it called? IoT hub and NQ time. There you go. And then I want to see the body, and I want to see it in a way that I understand it. So I'm going to print the bytes string. So let's give this one a spin, and hopefully we're going to see some real temperatures. So let's write here temperature. Very good. Now I am publishing again. And while I am publishing, just let me make sure that it's going through. Yeah, it did. Very well. Now this will take a minute or so before it gets updated. It will restart itself. It will do all that stuff. So in the meantime, we have something more to do. We have to create a logic app. So let's do that. Let's create a simple logic app. Create a logic app, and let's call it LA. Send email if to hot. Luckily this was available. West Europe, everything. Put it in consumption tier. Keep things simple. No tags, just review it and create it. Let's create it.
So Nikos,
Yeah.
in case of any person in this live stream doesn't know what logic app is, can you tell us a little bit about, like in short terms?
Absolutely. Yes. A logic app is a tool that Microsoft has created inside Azure to make it easier for people to perform tasks without knowing how to code. So a logic app consists of triggers and actions. So it's already ready, actually. That was a good coincidence. So we'll start with a trigger, and now we'll start with an HTTP trigger, meaning that I am going to trigger to start my logic app by sending an HTTP post request to that. And then after that, I'm going to perform some actions. And there is a large library that Microsoft has, which contains a lot of data, which contains a lot of actions. You can send emails, you can receive emails as a trigger, you can create stuff, you can run functions, you can send the data to the data factory or to service bus. You can really do a lot of things without having to know how to code. So those are getting more and more popular. And what I am about... Oh, sorry, we had a question. In the meanwhile, is there maybe a connector to IoT or Events Hub available from Power Automate? I really don't know the answer to that. Carlo, would you mind to take a look while I'm doing that?
Yeah, we'll check that.
To be honest, I'm not very familiar with the Power Automate suite. I know that it's really powerful, and I expect it to exist. Actually, it would surprise me if there were not. Remember to include the content type headers set to application session. Of course, I will. Got it. So let's create the body, the JSON schema. So I expect a value. I expect a property called temperature, and it's going to be string. Now, after that happens, I am going to put this in a variable. Do I even need a variable? I'm not really sure. I'm not really sure that I need, but let's make it in every case. Let's call it temp, and let's make sure that this is string initial value. Oh, we can take the body directly. Look at that. So we say that the initial value of this variable is going to be the body of the HTTP request. That is very handy. So what I'm going to do next is that I am going to send an email. And as you can see, we already did that yesterday. It's not as easy as it looks like when you're doing it for the first time. So to send an email, oh, now it's time for the temp mail. Temp mail. Here is my email address for today. It's getting hot. Sorry to annoy, but according to the sensor, it's getting hot. And I will also include the value that I have in my variable. Now, I can't help it but say that I could get it from the HTTP request, so maybe this thing is completely useless. But yeah, anyway, let's keep it that way. So now I have saved that, so that should be ready. And let's see, let's go back to the function and see how it feels. I can see that I had an execution or two. Let's see again in the function and monitoring.
I just want to point in there. I was looking up the question we got, and as far as I can found, Microsoft has documentation about integrating Azure IoT with the Power Platform and Power Automate.
Okay.
They also have a video on that, so I would say that check out Microsoft.
Link the video to the comments session. Yeah. Thanks, Carlo.
Okay.
Now let's see, we have some execution. And look at that. Here is the big thing, the body. And here we managed, our code worked. We managed to print the real temperature. Now, the only thing that's left, since apparently our code works, is, now let's call this temperature, since we know, and string, since we know that it's the temperature. Now, the only thing left to do is to double temperature, double parse temperature string. I'm not using try parse because I feel confident. And if the temperature is bigger than 20, yeah, let's say 21, let's make it easy for us. Then here is when I want to send an email by using the logic app. And I have the code ready for that. It's nothing really special. Let's put the code here. Now I remember that the logic app is expecting, the client, yeah, of course. Of course, I need, what did I do? Oh yeah, sure. No. Okay, good. No worries at all. Now, I don't remember if the parameter for the logic app should be called temperature. So let's check it out. Home, and let's go to the logic app and look in the designer. It is called temperature, that's right. And I am also copying the post URL, and I will put it, of course, I'm going to hard code it. No worries. Let's save. Now, let's summarize. What are we doing here? Task. Why are you sad? There you go. What are we doing here? First, we're printing the whole thing, the whole event data. This includes the body, but even some system properties. That's good. Then we deserialize the data to an object of the class that I created to make it easier to access those properties. Then I am converting the base64 string to bytes, and then I'm getting the string out of it. So in these rows, I have decoded the base64 byte string. Then I am logging the data just for good measure. And then I am parsing the string to a double, and I check if the temperature is more than 21. Else, I do absolutely nothing. Otherwise, everything looks okay. And then, of course, I'm not going to hard code anything here. I am going to put the temperature to string here. That's very good. And then here I prepare for the post request, which I am sending using an HTTP client, and I get a request. This looks good, I think, and I hope. So let's publish. And now this will take a minute or two, because what we have to wait for right now is that first of all, the Azure function is going to be created. Then we are going to, not created, I'm sorry, it's going to be updated. And every time it updates, it has to restart itself. And since we are in the conception tier, then things are not happening very, very fast, as you can imagine. But yeah, I actually have a way. I use the log stream to check. But yeah, no worries. Let's revise. What have we done? First of all, we created the Azure IoT Hub. So we started with that. We start with the middleman, the man in the middle, which is getting the data and is making it available to everybody else. Then Carlo created a virtual sensor that is generating random temperatures and sending them to the IoT Hub. Then we created an Azure function which subscribes to a topic that the Azure IoT Hub provides. And then if the temperature is over a random value, then we call a logic app, which in its turn is going to send an email. As easy as that. So let's see how things are doing. How are we going, Carlo? Are we still having temperatures?
Yeah, it's still sending.
Send away. Okay. Now, the funny thing is that we don't have to wait only for all the things to restart themselves, but we have to wait for a temperature over 21, or wasn't it? It was over 21. Yes. Now, if we get one, then we're going to get an email. Oh, look at
Actually,
that!
it wasn't right now.
It came already. It's getting hot. Now, look at that. Now we had an issue with the parsings and the conversions because of the coma. Now, okay. I hope that you can let this thing slide. So this
Yeah.
should be 24 point something. But as you can see, it's sorry to annoy, but according to the sensor, it's getting hot. So let's go back. And maybe we get more emails, actually. Yeah, look, another one. So now, oh, sorry, this was the first. 2493. What was the other one? 24.
It came two messages, one with 24.20 and one with 24.93. So
Yeah.
it may be.
Well, now we're going to get every minute like the 21.27, so even that works. I believe that everything worked fine as we expected it to. We can also check the rest of the logs. Do I have something? Yeah, temperature. Let's look for that to filter out the bad stuff. Look, temperature 24.93, 24.20, 20.19. So we didn't get that one. See, it worked. So to summarize, just for the good measure, let's see the executions in the Logic app. As you can see, yep, it was executed a number of times. So I believe that we can conclude that everything worked. And once again, what we did, we created a virtual sensor. We sent values to the Azure IoT hub. Then an Azure function picked those values. And if it beat the threshold, then it sent a message to a Logic app with the temperature, asking it to send an email to someone so that it sends me an email if it gets hot. I believe that that was all for today. We are 10 minutes late, 11. But I hope that those of you who stayed had a good time. Carlo, any closing words?
Yeah, it was fun to do this, and it will be even funnier the other days. So I hope to see many of you on the next couple of days too.
Likewise, likewise. Have a good evening, everybody, and see you.
See ya.
Bye.